Okay, here we go. This is Unit 3 um, for computer science. Basing this off of questions that you guys submitted on the forum, all 6 of you. So hopefully everyone else is expert at this. But problems that jump out at me were I'm going to start just doing ones that had more questions. So I'm going to look at 7, 8, and 9, which I think are related to each other. So 7 through 9 refer to the following information. Okay, so program to test the bank account savings classes has these. Okay, so actually we have to back up a second. So 1 through 10 all refers to these. So I'll probably just do several of these all at once. So let's read it real quick. Bank account, savings account, checking account defined below. Here's bank account, private instance variable, double balance, 0 hour constructor, 1 hour constructor, deposit, which is kind of like a setter, withdrawal, which is like it's a mutator, changes it, double get balance, that's a getter. Then we have savings account extends bank account. That means that this is a super class and this is a subclass. So it inherits all the private instance variables and methods, which we can either override, leave as they are, partially override, and then we could add new private instance variables. And here's the constructors and add interest. So that's that one. And then checking account extends banking account. So checking account is a bank account. So this is the subclass of this superclass, and it has static final. Double final means it's like a constant. We don't intend for it to ever be changed, and so we usually name these with capital letters. And then it has a constructor and all right, so let's see. No one had a question on number 1. How many different non-constructor methods can be invoked by the savings account object? So savings account was this one. How many methods besides the constructors can be invoked? So we have add interest, but you can also access deposit, withdrawal, and get balance. So I would say a total of 4. Does that make sense? So you have the private instance variables from within it, but then you also are the methods from within it, but then you also have the other methods. Number 2, which of the following correctly implements the default constructor for savings account? Implements means what is the code for the default? Default is 0 arg. Okay. So it needs to have a call to super first. So this one's wrong. It has to have a call to super, and it's default, so you don't give it any interest rate. But then you have to initialize the new instance variable. So I would say this is your best one, but it is possible to not initialize your private instance variables, and they will be set to 0 automatically. So that one's kind of tricky. So 2 is the best. 3 is okay. So it could be a 2 and 3, not 1 for sure. Which is correct implementation of the constructor with parameters for savings account. So we need to do super, and then we need to initialize the interest rate. So, but we also want to, let's see. So it takes, you got to look at the argument. So it takes an account balance and a rate. The account balance is needed for the super. So you need to do super with account balance and then interest rate if you want that to work out the way you hope to. These other ones, some of these are just weird. You can't do this because it's in the super class. So you got you got to call super first anyways. If you do this, it's calling the default super constructor, which you lose your account balance. So that's not good. Number 4, which is the correct implementation of the checking account constructor? So checking account constructor is right up here. It takes it. It doesn't have a zero argument. It takes the account balance. You need to do super account balance. If you do super without anything, then that just sets the account balance to 0, right? But then you do have access to the deposit method from the bank account class, so you could always put it in after the fact. And so that one is, this is the best one. This one works. This one you might say, oh, but where's the super? Well, if you don't call super, it by default calls the default constructor if you don't write it at all. So this one would work also. So that's kind of a tricky question. So this is really about knowing the ins and outs of Java, how it works, even in special cases. So if you don't put super, it is going to call super, but only the default version. So if you wanted to actually call the multi-arg one, it wouldn't work that way. But the fact that we can deposit it afterwards works in this case. No one had a question on 5. 6, redefining the withdrawal method in checking account class is an example of. So in the checking account class, they do have a withdrawal, and there was original withdrawal in the bank account class that it inherits. So we usually don't need to rewrite the headers for those. So if you do that, that's redefining it. That's called method overriding. Okay, overloading is when you create the same method with different argument types. So it's definitely method overriding. And then you guys had a lot of questions, more questions on 7, 8, and 9. So we'll take a look at those. These are referring to the same problem. So that's why I just want to kind of run through that first. A program to test bank account, savings account, checking account classes has these declarations. So it's declaring a bank account reference, bank account reference, bank account reference, and given a new bank account or new savings account, new checking account. Which method will cause an error? Now you got to be careful because even though these are all bank accounts, this one is specifically Cass's bank account. This one's Cass's savings account. This one's Cass's checking account. So depending on the one you have, depends on how you're going to access things. If you're in a savings account, then you got to call super to access the methods in the super classes. So B deposit. So bank, can you call deposit? Yeah. Can you do a withdrawal from a savings account? Does savings account have its own withdrawal method? It doesn't. It has an add interest, but let's see. But it does. I don't know. It should inherit that. The checking account, can you do withdraw? It will inherit the. And Java will polymorphically look for the right, method call. S deposit, savings account. Does it make sense to call deposit on savings account? Yeah, it's a subclass. Now S add interest. Add interest was specifically for checking accounts, right? And so this is a savings account, and savings account doesn't have an add interest. It was just checking account that had the, sorry, let me get this right. So we have add interest on a savings account. Which one would cause error? Okay. The problem, okay, so here's the problem. I'm backing up, now I'm remembering. If we make the references bank account, then you don't have to call super on here because it looks in bank account and finds withdrawal, finds deposit. but add interest is specifically in savings account. And so you would have to first cast the reference back as a savings account. I don't know if you guys remember this issue. So you would need to do savings account and cast S and then call add interest. Otherwise, Java can't find that method because it's looking from the bank account down. Now, if it was listed in bank account and just overrode later, it would do the right version. So it's going to be E. Okay. Number 8, in order to test polymorphism, which method must be used in programming? So polymorphism is when there are multiple versions of a method and Java will select the correct version. And so you would want to pick a method that has a new version of itself. So I think it was the withdraw method that got overrode in the checking account class. So you would want to call the withdraw method from a checking account or different object to see if it actually picked the right one. So that's polymorphism. Let's see. Number 9, which of the following will not cause an error? Not cause a class exception error. Now, class conception is when you try and cast something to an object that it cannot be cast as. So we can cast things to more broad objects like superclasses that they belong to, or more specific down to their specific object. And that's the reference. So this is all referring to these declarations. So B is a banking account, and it is a banking account. Can we make it into a savings account? No, you can't. It's a bank account. It's not a savings account, so you can't do that. Can you make the reference for B into a checking account? No, because this is a bank account. It actually not just the reference, but the actual object is a bank account. You can't make it into a more specific subclass of itself. C is a checking account. Its reference is initially a bank account, but we can make it more specifically a checking because C is a checking account. So I think that one's going to be the right one. And then we could call deposit on it. This is the thing that we're worried about. S is a savings account, which cannot become a checking account, right? And C is a checking account, which can't be made into a savings account. So you can change the reference to be, at first, all those declarations, the references are all bank accounts, but then we can make them more specifically into, what specific object they are. 10 says a new method is added to the bank account class, public void transfer. Program has these declarations. Bank account B is a new bank account. Savings account is a new savings account, and checking account is a new checking account. Which of the following will transfer money from one account to another without error? So the transfer method withdraws an amount from that current bank account and adds it to another bank account. It deposits it in there. So can we transfer 50 from Tim's, which is a savings account, and it has in its savings account reference also, and transfer it into B, which was a bank account? Now, can bank accounts receive deposits? Bank accounts can receive deposits, and so that works. Or could we take it from Dana's, which is a checking account? So does checking account have a withdrawal That it does. And then without an error. Okay. Withdraw the amount and $2 fees. Okay. So we can, and then we could transfer it to Tim's. Tim's is a savings account which inherits a deposit. Okay. So that should work. And can we take it from the bank account 55 and withdraw it, and then add it to Dana's checking account? So checking account. Yeah. So they're all good. 1, 2, and 3. So they inherit. These guys inherit the methods from bank account. All right. Okay, let's jump to 15, 17. Well, I guess we're going to do 15 first, and then 17 and 18. We can do 14, 15. Yeah. Okay, so we have a public class A, default constructor not shown, has a method. Public class B extends A. So extends this is the superclass, and this is the subclass, right? Or sorry, this is the superclass, and this is a subclass. Default constructor not shown. It has a public void method 1 that's different, so it's going to override that, and then it has another method 2. The method 1 method in class B is an example of method overriding. Okay. 15. Consider the following class declarations in a client class. So that's another class that has these objects in it. And says, which of the following method calls will cause an error? Will cause an error. Okay, so if I call method 2 on object 1 on an object, so object OB1 is a class A object, and if I try and call method 2 on it, well, class A doesn't, that superclass doesn't have method. Method 2 is more specific to that subclass, so you can't do that, right? This is a class B method, which is more specific. Can we call method 2 on object 2? Yes, because it's a class B. If I cast class 1 to class B object, then can I use it? No, because object 1 is a class A object. You can't cast it to a more specific version of itself. So the ones that will cause an error are 1 and 3. Or, oops, sorry. See, I ran into an issue here. Object B, OB2 is a class B object, but its reference is class A, so you have to cast it first because method 2 isn't defined in the superclass, so Java won't be able to find it. So you would have to do class B OB2 and then dot method 2 for that to work. Tricky. So none of them work. Crazy. Okay. Let's see. 17 and 18 are referring to this chunk of code, so we'll talk about that. So it's a public abstract class solid, like a 3-dimensional solid maybe or something. I don't know. It has a private instance variable string name. It has a 1R constructor. It has a getter. It has an abstract double volume. So this is a method that finds the volume and returns double. It's abstract, meaning they're not going to implement it here, but it will have to be implemented by a subclass. So sphere extends solid. So this is a subclass of the superclass solid. Solid is a common name for three-dimensional objects. Spheres are three-dimensional. Specifically to spheres, they have a radius in addition to their name. They have a constructor that takes the name and the radius and creates, it has to create the super first and then initialize its own provenance variables. It has a volume method that's specifically for the volume of a sphere, and that is the equation for the volume of a sphere. And then we have a rectangular prism, which has a length, width, and height. You guys know what a rectangular prism is. So we're getting all these different little geometry shapes here, right? Length, width, and height is what you need to find its volume as a superconstructor, its own volume. Okay, so we're going to use those. Number 17 says, which is false? If a program has several objects declared as type solid, the decision about which volume method to call will be resolved at runtime. Yeah, that's polymorphism, right? That's if there's several versions of it, it depends on like which object you're calling the method on, and Java will resolve that when it's running. If the solid class were modified to provide a default implementation for the volume method, it would no longer need an abstract class. Need to be an abstract class. I guess so. I guess that's one of the reasons. I mean, if we could come up with its own volume method, if the sphere and rectangular prism classes fail to provide implementation of volume, they would need to be declared as abstract classes. Yes, because you can't, you have to implement it in the subclass. The fact that there is not a reasonable default implementation volume method in the solid class suggests that it should be an abstract class. Yes, we can't just create just a general three-dimensional object that has a specific volume. So it makes sense that you're not going to just create a generic 3D object. You want to get it more specific. Since solid is abstract and its subclasses are non-abstract, polymorphism no longer applies when these classes are used in a program. No. Polymorphism is it'll pick the volume formula from a rectangular prism, or it'll pick the volume formula from a sphere, depending on which one. So that's polymorphism. This one is false. Number 18, here's a program that prints the volume of a solid. Prints it. So like prints it out on the screen. So it's called public class solid main. It's a separate program. Public static void print volume. Now static means it doesn't belong to a specific class or a specific object. It's not a behavior for a specific object. So this is going to be used for different objects. Public static void main. So this is a static method, meaning that we're not going to actually create a solid main object. Okay, and this is going to get used in this class. So we create a solid. We create another one called SPH, which is a sphere. You create another one called REC for its rectangular prism. Int flip coin. This is like imitating a heads or tails flip. Math.random times 2 would give you 0 to 0 point or to 1.99999, right? And then you cast it, so that just truncates it. You're either going to get a 0 or you're going to get a 1. And you kind of have 50-50 chance of it being, halfway between here and halfway between here. If it's a 0, then let's assign the sphere to that solid. If it's 1, then we're going to assign it the rectangular prism. Then we're going to print out which is a true statement about this program. It will output the volume of a sphere or box as intended. Yeah, I think so. Yeah, right? I mean, we're going to get one or the other. It will output the volume of a default solid S, which is neither a sphere, not or a box. No, it's going to give you a sphere or a box, and you can't even do the volume of a solid because it's abstract and doesn't have, a class cast exception will be thrown. The only no, we're not trying to cast any classes, and we're not trying to do. I don't know. No. Down here, we call volume on S. Okay, so yeah, a compile time error will occur because there's no implementation code for volume. No, because we're going to pick the rectangular prism or the sphere before we make the call to volume. Okay, if we tried to call volume on S before we assign something else to it, that was a specific one, then yeah, we get a compile time error. A runtime error will occur because of a parameter type mismatch in the method called print volume sol. So parameter type mismatch. You're asking for a solid and you're going to call no, I don't know. So the most, I know it seems too good to be true, but the first one that sounds the most straightforward is the true statement. Okay, I'm going to jump to 20 and on, and then I'll come back maybe and do some of the ones that just had one question. Okay, consider the player interface. So interface is a way of grouping common behavior, but it's not a class. And you can extend a single superclass, but you can implement multiple interfaces. And so interfaces are just sort of listing behaviors, and they are usually abstract, and then they get implemented in the classes that implement those interfaces. And that's a easy way to remember that you got to use the keyword implements. So we have a player has a get move. Now, public, abstract, would be more thorough name for that. But the public and the abstract are just by default applied by Java if you don't put them. Okay. So both these public, abstract. Okay, and so they have no implementation. They just have the return type and the name of the method and the arguments it takes, but it doesn't have the code for it. 20, human player is a class that implements player interface. Another class, smart player, is a subclass of human player. Which statement is false? So you have human player that implements player interface, and then smart player is a subclass of human player. Smart player automatically implements the player interface. No, because, well, let's see. Smart player automatically implements the interface, player interface. Automatically. Yeah, I mean, it inherits it from human player, right? Class implements this. Human player implements it, so automatically, human player must contain implementations for both update display and get move methods, or be declared as abstract. True. Okay, so human player is going to take care of this. Smart player is going to inherit those automatically, right? It is not possible to declare a reference of type player. It is not possible. It is possible because player is going to implement those. So they're not going to be abstract. So this is the one that seems wrong. It is possible. The smart player class can override. Sure, smart player class can override those methods. Like general, subclasses can override their subclasses methods. A method in the client program can have player as a parameter type. Yes, because method can have player as a parameter type. So something that you take in. Sure. Yeah. Okay. So, some of these are just kind of weird, and I don't feel like we see any that are this kind of vague. So 21, just read what they have in the Barrons, or the explanation of what they say, of like these kind of questions. It says it may or may not be suitable for these classes. Which is the least suitable for having the competitor class to implement? Okay, so it's very like, well, this one they might be all bad, but this one's worse. Just read that. I don't think you have to worry about that kind of question on the AP test. 22 and 23 both use this information. Consider these declarations well. Public class, human player implements player. So are we still working with? Yeah, we're still working with that player stuff. Okay. So we have public class player implements player. So here's the code that it seems like they're referring to. It has its own private instance variable string, constructors, code to implement, get, move, and update display, and then it has a getter. And then it has public class expert player extends. So implements is for interfaces, right? Because that means you're going to write the code for the methods that they listed that were abstract. Extends is for a subclass. That's where you take one class and you make it, you add on to it, you extend it. Has a new private instance variable rating, constructors, has a compare to method that takes another expert player to compare to the current expert player. So 22, which code segment in a client program will cause an error? Client program will cause an error. So something that won't be allowed to be called. So we're going to create a human player, expert player of player reference. So we're making the references more more broad. And then we're going to call get move on both of these. Now, I guess the question is, does the player have get move in it? Even if we override it, it'll pick the right one. But if it's not in that superclass as a method, then Java won't be able to find it. So did the player class have a get move? Okay, sorry, player is the interface. So call get move. Get move is listed in here, so then it'll keep looking down and pick the best one. So that one's fine. Now, if get move wasn't in the interface, then, and even though it was in these objects, because the reference was of the interface type, it won't be able to find it. The next one, we make two expert players of player reference, and it says if C1.compare to C2 is less than 0, so that's a compare to method, then call get move. Now, the problem here is that these are player references, and compare to was specifically a method in the expert player class. It wasn't listed in the interface, so Java's not going to be able to figure out what to call here. You would need to downcast your references first. So you would need to say, okay, well, let's make the reference C1 into an expert player. And you could do this as you're going. You could downcast it and then call compare to, and then you would have to do the same. I don't know if you really have to do the same for the other one. Yeah, because it's expecting something of an expert player reference in the program. So you would need to do something like this to make that work. So this one's not going to work. Human player. The the actual object and the reference type are exactly the same. Does human player have a compare to? It doesn't, right? A compare to is specific to expert player, which is a subclass of human player. So, and you can't even cast these. Okay, this is from the expert class. You can't call the more specific methods for objects that aren't those specific objects. So this one just can't be done. This one you could fix. This one just can't. You can't do that. So which ones will cause an error? 2 and 3. Okay. Number 23, which of the following is the correct implementation code for the compare to method? Okay. Well, I guess we're comparing their ratings, and so we want, to return a positive usually if something's bigger, negative if it's smaller, 0 if it's tie. So if they both have the same, if the current rating of the current expert player equals the other, this is the other expert player that got brought in. So if you look at this, it brings in another expert player, calls it expert. So that's the one you're comparing this one to. And so if they're the same, it's 0. If the current rating is less than the other guy's rating, then we should return a negative. Okay. And if otherwise, return a positive. So that one looks good. Return the current rating minus the expert's rating. Now, this is another way we could do it. It's not going to return a negative 1 or 1, but it'll return a positive if this one's bigger, a negative if this one's bigger, and a 0 if they're the same. So this would actually give us, usually with compare to, we say, is it positive? Well, that means that this one's greater. Is it negative? Then that means this one's less. Are they the same? Then it'd be 0. So that one's fine. The third option, if get name dot equals expert get name, return 0. So instead of comparing their ratings, I guess we could compare their names. It didn't say anywhere that we had to compare ratings. And so maybe we're going to return compare to returns comparing their names. So maybe like alphabetical or something. So if they have the same name, return 0. Okay. Else if the get name of the current one. So this is using the compare to method from the string class because these are strings. So the string class already has a compare to. And it says if this one is alphabetically before this one, then we return a negative. And if it's alphabetically after, then we return a positive. So I think they all could work. 1, 2, and 3. Let's see. No one had a question on 24, so I guess I'll skip 24. 25 looks like another, let's see, maybe potentially kind of broad, vague. What's the best? What's the worst? Least suitable? But let's take a look at it. A programmer has the task of maintaining a database of students of a large university. There are 2 types of students, undergrads and grads. About a third of the grad students are doctoral students, so there's even more specific. And so, I mean, we could kind of we could say, well, we have students, and then we have grad, undergrad, and then and then here we have doctoral. So this is kind of my little UML diagram. Just okay. It says all of them have the same personal information stored, like name, address, phone number, also student information like courses taken and grades. Each student's GPA is computed, but differently for undergrads and grads. So GPA should probably be an abstract method in the superclass, and then we'll implement them more specifically. We'll override it. But in the subclasses. Doctoral candidates have information about their dissertations and faculty advisors. So the difference between grad and undergrad right now seems like they just have different GPA methods. Doctoral has more private instance variables. The programmer will write a Java program to handle all the student information. Which of the following is the best design? So that's kind of subjective. In terms of programmer efficiency and code reusability. Okay, so like don't rewrite things. So they're saying they're going to create an interface for students. I don't think that's good because they have all kinds of common private instance variables. I don't think we should create an interface. We should create a class and maybe an abstract class. Extends. That one seems promising. We could create just a non-abstract class, but I don't think we're going to make just a regular old student. So that's the thing about this one that isn't as good. We could doc student extends grad student, undergrad. Okay, so the rest of that looks fine. This one has abstract class student, undergrad extends student, grad extends student, doc extends student. No, doc should extend grad student because it already has those things in common. We shouldn't have to rewrite the stuff from graduate into doc student because doc students are graduate. So that one's no good. Actually, that one was good. And then, or we could do interface personal information, and then public class student implements personal. So we're going to create an interface, and then we're going to put it in a non-abstract class student, or but this should be abstract, and let's just put it all in there. This is just making it more complicated than it needs to be. So the best answer, I would say, is B. And we're getting close to that just by reading it. 26 and 27 had a lot of questions. So 26 said, consider the orderable, something you can order, I guess, interface, and partial implementation of the temperature class defined mode. Partial implementation means they just show you some of the code, but there's more code. They're just not showing it to you. So interface orderable, there's one method, it's called compare to. Returns -0 or 1 depending on whether implicit object is less than, equal to, or greater than. Less than, equal to, or greater than. That's kind of what we already talked about, is a common way of using compare to. So public class temperature implements the interface, right? Implements is the key word because it's going to give you the code now because there's no code here. It's not a subclass, superclass thing. It has private instance variables, it has a constructor, it has a multi-or constructor, it has the compare to, which it has to, and it has a toString. Bunch of common stuff. Here is a program that finds the lowest of 3 temperatures. Okay, so it has temperatures. Each temperature object has a value and a scale, like Celsius or Fahrenheit. Here's a program that finds the lowest of 3 temperatures. So public class, temperature main, public static, orderable. So it's going to return an orderable object of orderable type, interface type. It's going to take 2 orderable type objects, and it's going to call compare to. So if it compares, it does A compared to B. If A is less than B, then it's going to return a negative. Okay. Find smallest of objects A, B, and C, public static, orderable, min3, orderable A, orderable B, orderable C. So we're trying to find the smallest of 3. Let me figure out where we're at here. Okay, find the lowest of 3. So we're taking 3. And what they do is they say return the min, and there's this, the min of, now it finds, what's it going to do? It's going to find the min of these 2, and then it's going to find the min of these 2, and it's going to return it. Public static void main, code to test min3 method. Wow, that's a lot of information to digest. Which are correct implementations for the code to test min3? Now, I'm assuming that this min method, oh, that's the method right up here. Okay. So what it does first is it compares A to B and returns the smallest. Then it compares the smallest of those two with that and returns the smallest. So it breaks down because you can't compare. Our min program only takes 2 at a time. So how to compare 3? Well, you do 2, find the winner, and then compare that to the other leftover one. So we have temperature T1, which is Celsius, Fahrenheit. It didn't say anything that we can't compare different scales, Celsius or Fahrenheit. So this is, which is the correct replacements for code to reset. Essentially, this is the driver, right? We're trying to test this code. So if we create the 3 temperature objects, and then we call min3 on, I don't know, it seems like that should work. If we make them, now here's the big difference. So we got to think about, does that make a difference? And if it does, what is the difference? Now, this requires you to give it orderable. It's expecting orderable arguments. So that's the place I think that's bad here. Here we're going to make the references orderable. So now it does recognize them as orderable, even though they're temperature. So I think this one's which one here? Takes orderable and temperature. Well, no. So this is going to work. So because temperature is an orderable because it implements it. So Java will recognize that. This one right here, we're making them orderable objects, which is impossible. This is just not possible. It's an interface. You can't create an orderable object. You can make the reference of that type, but this one is just straight out for sure bad. So we're going to go with 1 and 2. So it's interesting, and you can read the Barrons and read up on it, that if something does implement that interface, then it will be accepted as that type as an argument. 27 says a certain interface provided in Java package contains a single method. Okay, some public abstract method called method 1 returns an int, takes an object, which is the most highest superclass level in Java is just object. Everything in Java is a subclass of object. Capital O. A programmer adds some functionality to this interface by adding another abstract method to it. Okay, so now now it has another method that's void. As a result of this addition, which of the following is true? A class cast exception will occur if OB1 and OB2 are not compatible. Not compatible with each other, or they're in different methods, so I don't really know what they have to do with each other. All classes that implement the original subname interface will need to be rewritten. So if you write this interface and then you have a class that implements it, then it has to put the code in there. It has to implement it, right? If you go back and you change your interface, you're going to have to go back and fix all the classes that implemented the first version. So I think that one's the true one. A class that implements the original subname will need to modify its declaration to implement subname extends method 2. That just doesn't make sense. That's like superclass, subclass stuff. That's just weird. Subname will need to be changed to an abstract class and provide implementation code for method 2 so that the original and upgraded versions of subname are compatible. Well, that won't work. If you change subname to an abstract class, the methods that implemented the original interface are still going to have problems because they're going to be trying to implement a superclass now instead of extending it. So that's definitely not going to work. Any new class that implements the upgrade version of some name will not compile. Any new class? I think it will compile. Yeah, so I'm going to go with B. Okay, so I hit all the main questions. I could go back through and see if there's any I skipped. And I hit a lot of the lesser asked questions just because we were doing other questions at the same time. But we could just double check and see if there's any few more I could do in the next few minutes. We did all those. I think I skipped 11 and 13, so we could take a quick look at those. So 11 says consider the class declarations person and teacher extends person. So this is the subclass and this is the superclass, and we say that's an is a relationship. A teacher is a person, right? Which is a true statement. Teacher inherits the constructors from person. Yes, it does, or at least the default constructor. So I mean, but you're still going to have your own constructor. So I mean, constructors aren't methods. So in methods, when we think of inheriting, those are things we just don't need to put at all. So we're going to say no on that. I mean, you can, if you still have to put a constructor for teacher, I guess is the idea. You don't have to call super if you are intending to use the default constructor from the superclass. Teacher can add new methods, of course. Teacher can override existing private methods. No, they have to be public. Private is going to also restrict access to even subclasses. Okay, private means that only can be seen from within that class. And even if you have a subclass of that class, it still can't be seen. It inherits it, but you can't change it. So it's just going to be 2 only. Okay. 13 says consider the following hierarchy of classes. A bird, pear is a bird, owl is a bird. A parakeet is a parrot, which is also a bird. A program written to print data about various birds, public class bird stuff, public static void, print name, public static void, print. Okay, now these are static because they're methods in the bird stuff class, and we're not going to make bird stuff objects. Okay. And then we have public static void main, that common thing. That's why we put static, because this is for a class that we're not going to create objects of. Okay. We create bird one of reference type bird and just generic bird, parrot, parakeet, parrot. Okay, so we're looking for maybe potential issues with calling methods. Anyways, assuming that none of the given classes is abstract, meaning they all have constructors, so there's no problems with creating a bird object. If the superclass was abstract, then we would have a problem with that. And it says which of the following segments will not cause an error. Print name. Now let's see. Let's look for print name. So print name is a method and print bird call, and it takes a bird. So print name expects a bird. Parrot 2 is parrots are birds. Okay, print bird call. Now print bird call only does it for parrots, and bird 2 is a parrot, but the reference you can downcast it. You're allowed to do that. And so that seems okay. Here, we're going to downcast bird 1 to a parrot. You can't. That's not possible because bird 1 isn't a parrot at all. So that one's out. You also can't put it in bird call because it's not a parrot. Print name bird 2. Bird 2, that's fine. Bird 2 is a parrot, but you have to downcast it. To parrot. So you'd have to downcast it. When you put it in. And I guess same thing on the previous one for the second part. Per name, parrot 1, we're going to downcast to a parakeet. Well, no, it's not a parakeet. You can't do that. We have the same issue in the next thing that we did on the last one. So we could downcast that. So that one's out. That one's out. We're going to cast a parrot as an owl. Parrots aren't owls for sure. It's not possible. So you got to make sure that would be a class cast exception. If you try and cast something as something that cannot be cast as. Okay, so that's going to be A. I'm just trying to see if there's any other questions. I guess 19 says consider the computable interface, simple calculator operations, add, subtract, multiply. These are all abstract. Which is the least suitable class for implementing computable? So this is, I don't know, don't stress too much about these. Read what they say. It's good information, but I don't think you're going to have to do this on an A/B test. Large integer, integers with 100 digits or more. Would it be okay to add, subtract, multiply? Yeah. Fractions. Can we add, subtract, multiply fractions? Sure. I mean, that's the first thing to just think about is, does it make sense to add, subtract, and multiply these kinds of objects? Irrational numbers. Sure, you can add, subtract, and multiply lengths. Can we add lengths, multiply lengths, and subtract lengths? Sure. Bank accounts. Can we add bank accounts, subtract bank accounts, multiply bank accounts? This is the one that makes the least amount of sense there. So, anyways. And so I think the only other question I skipped today was 24. So we could take which of the following classes is least suitable candidate for the compare for containing a compare to? Can you compare points? Yeah, I think you compare their X and Y values. Maybe, can you compare names? Oh, for sure, compare names. Can you compare cars by year or price? That makes sense. Students with names and GPAs, yeah. Employees. So even though you might think you can compare points, but it's the least obvious of these ones. So anyways, that's it. Submit your questions for the next one so I can answer them.